Hello, and welcome to my video for Assignment 2, Part 2 for Computer Networking. To preface things, I'd like to mention that this current implementation will look very similar to my part for Submission 1. However, importantly, none of the routing table values are hard-coded anymore, like they were in my first video. This means that there is now a full network controller instantiated, and that handles connecting all devices on the network, and it provides routing information in response to any request for routing information from the devices for when it receives a packet where it does not know where the destination is. Let's have a quick overview of how it works. I have focused my sights on the controller class for the past week or so, and it is now fully developed to the point where it maps all new devices on the network into its own internal map of the network using the node class you can see here on the right. This node class is very simple. It contains the name of the device, the address, its type, which is either an endpoint, a router, or the controller. It contains a list of devices it's connected to. These are devices that are on the same subnet as any given device, and then the routing table for each device, which is instantiated on a need-to-know basis. When any device is connected to the network for the first time, it sends a new type packet to the controller. This contains either its name or its IP address, depending on whether it is an endpoint or a router. Upon receiving this information, the controller then creates one of the aforementioned nodes and connects it to any other devices on the same subnetwork as it. However, for today's demonstration, due to time constraints, I have only been able to test it on one subnet. However, I suspect that with a tiny bit more work, I'll be ready to go for the final submission and be able to handle devices across multiple networks. When a device receives a packet that it does not know the destination for, i.e., the destination is not stored in that device's routing table at the present time, it sends a routing request to the server, and the controller uses this information to plug it into my findRoute method, which iterates through all the nodes in the graph to find the destination route and then return the route. The routing tables are stored in Python dictionaries, which use the following format: the destination IP followed by the next node in the route. This means that every node only knows what the immediate node after it in order to get to a given destination instead of the entire route. This can cut down on the amount of data that needs to be transferred between the controller and individual endpoints and routers on the network. Now let's take a look at this in action. To start off, I'm going to launch the network controller. So now that the controller device is started, let's start our endpoint devices. We are prompted to enter the username for this device. It's worth noting that this name is how any other endpoint devices will know how to message this given client. So for demonstration purposes, I'm going to go with Alice. And we're going with Bob for our second device. Let's send a message from Bob to Alice. We use this using the updated send command, which includes the recipient's name. So send Alice hello. We can see that the client has received a request for routing information and then passed it back to our endpoint device for Bob. If we run the ls command for Alice, we should see the new message received. And there we go, a message hello from Bob. I'm going to send another message back to Bob. Send Bob, how are you? As we expected, the how are you message is received on Bob with the timestamp and the username Alice. We can continue this conversation as much as we want, but let's hop over to Wireshark to see the network packets being sent. In Wireshark, we can see all of the UDP packets sent during the initialization stage and also in the message transfer. Our first packet here is a new device packet from Alice sent to the controller. Here we see Bob's new device request. This is a request from Bob to the controller to find network routing information to send a packet to Alice. And this is the controller's response to Bob, containing the IP address for Alice. Bob will then store this IP address in its own routing table. Here we see Alice's endpoint requesting routing information from the controller in order to send a packet to Bob. And this is the reply from the controller containing this routing information. The next step for this solution will be to thoroughly test handling devices across multiple networks with their own subnets and interconnected routers in between them. Presently, the router is fairly well implemented, but for the purposes of this demonstration, I have decided not to launch it. As always, you can find the code for my implementation in my Github repository, which, if you are watching on YouTube, will be linked in the description of the video below. Thank you so much for watching.